Hello everyone, we're going to work on the worksheet number 12. The first question continuous on the interval, closed interval 1 and 5, and has absolute minimum at 1, absolute maximum at 5, local minimum at 4, local maximum at 2. You may sketch another graph or something like a version of this one, but this is a correct graph that you may want to have. So we would find 1 as the absolute minimum because it is closed interval. So we would have closed interval, close point at 5. And maybe we can draw it like this, and then less than this, and then moving up. This is one way of drawing the graph. You may draw another one. Number 2 is about sketching the graph of a function that has a local minimum, local maximum at 5, and it is continuous but not differentiable. One of the easiest ways to draw a graph which is not differentiable is to make a corner here. So maybe this is a good one. Number 3 is about sketching a graph of a function that has a local max at 5 and it is not continuous. So we can draw a graph like this. If this is 5 and we need to have local max, but it is not continuous. So this one can be a good one. Or you may draw another one. And we don't have any domain here. It's about all x values. Let's move on to the second page, which is about sketching a graph, a piecewise function. We know that the first one is a quadratic function, and if it was x squared, this will be u-shaped like this. It is minus x squared, it will be something like this, and it is 4 minus x squared, so it will be moved up 4 units. And the easiest way, because we don't want the whole graph here, we want a part of graph. The easiest way to find that part that is needed on this function or on this graph is to apply these 2 points to plug them in and find y value or f of them. So f of 0 is 4. The first point is 0 and 4. This is 0, 1, 2, 3, 4, and it is an open circle because we don't have equal sign here. F of negative 2 is 0, and it is closed interval, closed circle here. So we know that it is quadratic function facing down. So this is the graph. We know that 2x minus 1 is a line. And for drawing the line, we need 2 points. The easiest way is finding f of 0 and f of 2 and then connect them. And both of them are closed circle or filled circle. So if you plug in 0, you would get negative 1. If you plug in 2, it will be 3. So 0 and negative 1 is the first point. 2 and 3 is another point, and then connect them as a line. Next one is about finding the critical numbers. Based on the definition of critical numbers, numbers that make the denominator 0 or undefined would be critical numbers. So first of all, we would find the derivative. It is 3x squared plus 12x minus 15 here. We can factor out 3. We're left with x squared plus 4x minus 5. And we can rewrite it as x plus 5 times x minus 1 equals 0. So x is either negative 5 or 1. So these are two critical numbers. For number 6, we would find derivative, which is quotient rule, derivative of the numerator, which is 1 times denominator, minus derivative of the denominator, which is 2p times numerator, all over denominator power 2. So by multiplying them together, we would get p squared plus 4 minus 2p squared plus 2p all over p squared plus 4 squared. After simplifying, we would have negative p squared plus 2p plus 4 over p squared plus 4 squared. This one should be 0. We know that the fraction is equal to 0 when the numerator is 0. So this one equals 0. We would use quadratic formula, and we have negative 2 plus or minus square root of 4 plus 16 over negative 2. So we have 1 plus or minus square root of 5 as critical point. Number 7 here, again, it is product rule. So f prime of x for number 7 is derivative of the numerator, which is 1 over x, times denominator, which is x squared, minus 2x times ln of x, all over x squared to the power 2, which is x to the fourth. After simplifying, we're going to have x minus 2x ln of x all over x to the fourth. We can simplify x from the top and bottom, so we can factor out x, and we're left with 1 minus 2 ln of x over x to the fourth. We can cancel out x, and we would have 1 minus 2 ln of x over x cubed. And if this one is 0, it means that 1 minus 2 ln of x is equal to 0. It means that ln of x is equal to 1 over 2. And from this part, x is e to the power 1 over 2, which is approximately 1.65. Okay, let's move on to the next one, number 8. It's about finding the absolute maximum and minimum on the given interval. So for finding maximum and minimum, we're going to find f prime. And in here, the overall function is a power function. So we would write power, the expression itself with a power 1 less, and derivative of the inside, which is 2x. So altogether, 6x times x squared minus 1 squared equals 0. It means either the first one is 0 or the second one is 0. We don't need the power 2 because power 2, after taking root, it will be x squared minus 1. From the first one, we get x equals 0. From the second one, we get x equals either positive or negative 1. And we need to find y values. F of 0, if we plug in the function, will be negative 1. And f of 1 will be 0. F of -1 will be also 0. And f of 2 will be 27. So by comparing all these, we would set 2 and 27 at the maximum point, or the maximum value is 27. Okay, this one is max. And the least one, which is -1, is the absolute minimum. So this is absolute minimum, this is absolute maximum. And you can use sign chart also if you want. Number 9 is a quotient function. So finding the derivative is 2x as the derivative of the numerator times denominator minus derivative of the denominator, which is 2x times the numerator itself, all over x squared plus 4 power 2. So if we multiply them together, we would get 2x cubed plus 8x minus 2x cubed plus 8x all over x squared plus 4 squared. After simplifying, that would be 16x over x squared plus 4 squared. And if this one is 0, it means that 16x is 0. It means that x is 0. And we know that f of 0 is -1 because it will be -4 over 4. Now it is time for finding f of -4 and f of 4. Both of them will be 3 over 5. Now, by comparing these three amounts, we would see that -1 is the absolute minimum, and these two, both of them will be absolute maximum, which is 3 over 5. Next one, number 10. Next one will be number 11. No, number 10. So number 10 is here. Okay. Please read the question, pause the video, and then listen to the solution. Okay, based on the question, C of t is 8 times e to the power -0.4t minus e -6.6t. And the interval is 0 and 12. So we need to find the derivative for this one. Since it is exponential function, we would write it as it is a chain rule and also exponential function. So derivative of the power, which is 0.4 times a copy of this. Negative times negative would be positive 0.6 and a copy of that. We want this to be 0. We know that 8 never goes 0, so you would rewrite at -0.4 e to the power -0.4 t would be equal to -0.6 e to -0.6 t. And then by dividing the both sides by e to the power, so both sides dividing by e to the power -0.6 in order to use the power rule, we would get e to the power negative 0.4t minus, not here, minus, okay, before this, let me fix it. Before dividing by e, we would divide it by negative 0.2 to get rid of the numbers somehow. So we are left with 2e to the power negative 0.4t equals 3e to the power negative 0.6t. And now we're going to divide by e to negative 0.6. It will be 2e to negative 0.4t over e to negative 0.6t. This one is t equals 3. So using the power rule, which says base function, same bases, different powers, we would subtract when they are divided. So negative 0.4t minus negative 0.6t equals 3 over 2. So e to 0.2t will be 3 over 2, and t will be ln of 3 over 2 over 0.2, which is t here. Now, based on the question, we know that c of 0 is 0. And we know that c of ln of 3 over 2 all over 0.2 by replacing and using calculator will be approximately 1.185, and c of 12 is approximately 0.0599. Based on these three amounts, we would say that the maximum is this one. Let's move on to number 11, finding the intervals here. So in order to find decreasing, increasing, inflection point, and concavity, we are going to find first and second derivative. As the first derivative, it will be 12x squared plus 6x minus 6 equals 0, which means we can factor out 6. We're left with 2x squared plus x minus 1 equals 0. And then it will be factored out as 2x minus 1, x plus 1 equals 0. So either x is 1 over 2 or x is negative 1. We can have the sign chart for f prime. We can write 2x minus 1 and x plus 1. We don't have to write 6 because 6 doesn't make any changes. So numbers in order will be negative 1 and 1 over 2. For the first one, 2x minus 1, this one is 0 at negative as 1 over 2. So left part negative, right part positive. And x plus 1 is 0 at negative 1. Left side opposite of the sign of x. After that, plus. Altogether, negative times negative is positive, 0 because they are multiplied, they are not divided, and negative, positive, negative, 0, and positive. So it means that the function is increasing, decreasing, increasing. And when it is increasing, then decreasing, it means that we have a maximum here, and the maximum is f of negative 1, which is 6. The second part, decreasing, increasing, it means that you have minimum here, and the minimum is f of 1 over 2, which is negative 3 over 4. Now we are going to find inflection point. For finding that, we need to find second derivative, which is 24 x plus 6 equals to 0. It means that x will be negative 1 over 4. And finding the sign of this by having 24x plus 6, it is 0 at 1 over 4. Before that negative, after that positive, it means concave down, concave up, and negative 1 over 4 will be inflection point. And the point is negative 1 over 4. And when you replace negative 1 over 4 in the original function, it will be 21 over 8. Now we are going to use all these signs and the sign chart to graph it. Let me erase the board. Okay, so first of all, we would draw the points. The points were negative 1 and 6, negative 1, 6 here, and 1 over 2, if this is 1, 1 over 2 is somewhere here, and negative 3 over 4 maybe here. And another point was negative 1 over 4 and 21 divided by 8, which is 2.6. So negative 1 over 4 and 2.6, maybe here. One of the things that you can do is finding x-intercept, y-intercept. X-intercept, when you said y equals 0, is not easy to find here. So let's forget about this one. But if you plug in x equals 0, would be y-intercept, which is easy to find. So f of 0 is 1. Now, this is another point. We call it helping point. We're going to use that. So 0 and 1 is a point that helps us here to draw the graph. Based on the sign chart, we have maximum here, we have minimum here, and we have inflection point here. So before inflection point, it was concave down. And after it, crossing the y-intercept, it will be facing up because it is concave up. Okay, let's move on to the next one, which is number 12. For finding all these points here, we are going to find f prime of x. Again, quotient rule, it will be 2x times x squared plus 3 minus 2x times x squared all over x squared plus 3 squared. So after simplifying, this will be 6x over x squared plus 3 squared. And if it is 0, it will be x equals 0. And we would use this in order to draw the table, the sign chart. In here, we have 6x and we have x squared plus 3 as the parts of f prime. We know that 6x is 0 at 0, before that negative, after that positive, but x squared plus 3 is always positive, not even 0. So we don't have 0 for the denominator. F prime is 0, this one negative, this part positive. It means that before 0, it is decreasing, after that, it is increasing. So we have decreasing, increasing. It means that we have a minimum, and the minimum is f of 0, which is 0 here. For inflection point, if any, we're going to find f double prime. So it will be derivative of the numerator times denominator minus derivative of denominator. This part, pay attention that this is a chain rule. The overall function is a power function, so 2 times the expression with power 1 less, which is 1 times derivative of the inside. And it will be multiplied by 6x, which is the numerator, all over x squared plus 3 to the power 4 because it was 2, and again, power raised to the power 2 will be 4. Okay, and then after simplifying, you would get 18 times 1 minus x times 1 plus x, all over x squared plus 3 to the fourth. And when you get set this one 0, you get x equals 1 or x equals negative 1 as the points that they may be inflection point. So we're going to use sign chart to see what happens around these points. 1 minus x is 0 at 1, so positive, negative, because left side, the opposite sign of x. 1 plus x is 0 at negative 1, so this part negative, positive. And f double prime, we wouldn't consider the numerator, because the denominator, because it is always positive. So negative, positive, negative, and 0 at these points. Concave down, concave up, concave down, and these are inflection points. The points are negative 1 and 1 over 4 when you plug into the original function, and this one 1 and 1 over 4 when you're plugging at the original function. So using all these information, we know that the points that are important to us are negative 1 and 1, both of them with a y value 1 over 4 and 0 and 0. Okay, pay attention here that between negative 1 and 1, it is concave up. Okay, and negative 1 and 1. But from negative 1 to 0, based on the f prime, since it is left part of 0, it is decreasing. It means this way. And it is, it is concave up. It means this way. After that, it is still concave up, but it is increasing. So concave down here, concave down here, and left part decreasing, right part increasing. Okay, let's move on to number 13, which is trig function. For 13, we have the interval 0 and 2 pi. So we're going to find the derivative, which is f prime of t equals 1 minus sine of t, and we would set it 0. It means that sine of t will be 1. Using the unit circle, we would find it out that t is pi over 2. There may be other points, but they are not between 0 and 2 pi. For the second derivative, it will be negative cosine of t. And by setting this 0, we would find out that cosine of t is 0. It means that t is either pi over 2 or 3 pi over 2. And also there may be other points, but they are not between 0 and 2 pi. So using the points pi over 2 for 1 minus sine of x, or t here, and f prime. Okay, pi over 2 makes this one 0. Before that, you can choose any argument less than pi over 2, let's say pi over 4. Sine of pi over 4 is square root 2 over 2. 1 minus root 2 over 2 is a positive amount. We don't have to find that. The sign is enough. After that, between 0 and 2 pi, but more than pi over 2, you can just pick an easy one like pi. We know that sine of pi is 0, so 1 minus 0 is still positive. So it is increasing and also increasing. It means that you don't have any maximum or minimum here. But the point is important. So pi over 2, if you plug in here, you get pi over 2 plus cosine of pi over 2, which is 0. So pi over 2 will be the answer. Now, using the points for f double prime, which are pi over 2 and 3 pi over 2, and the function is negative cosine of t. So at these points, it is 0. Before that, using any number like pi over 4 or any other one that you know, this would be negative. Between pi over 2 and 3 pi over 2, the easiest one is pi, which is -1, but negative cosine would be positive. And after that, you can use any number like 2 pi is the easiest, I guess. That would be negative. So it means concave down, concave up, and concave down. So you have inflection point here and also here. And by plugging them in the original function, we had pi over 2 and pi over 2 here. We're going to find 3 pi over 2 when you plug in 3 pi over 2, and the cosine of 3 pi over 2 is just 0, so y value would be 3 pi over 2. And using these two sign charts, we are going to draw that. Starting 0 and 1, because if we plug in 0, we usually find these two amounts. So 0 is 1. If this is pi over 2, pi, 3 pi over 2, and 2 pi. If you plug in 2 pi, you would get 2 pi plus 1, maybe somewhere here. Between 0 and pi over 2, it is increasing but concave down. So the point is pi over 2 and pi over 2. It is increasing but concave down. Next point is 3 pi over 2 and 3 pi over 2, maybe somewhere here. Between pi over 2 and 3 pi over 2, it is also increasing but concave up. And between 3 pi over 2 and 2 pi, it is still increasing but concave down. So this is the graph. Let's move on to the next page. 14. So first of all, we are going to summarize whatever we have here for f prime. For f prime, based on the question, before number 2, it will be positive, it will be increasing. So increasing here. After 2 is negative, means decreasing. So when it is increasing, decreasing, we would have maximum here at x equals 2, and we don't know what f of 2 is. For f double prime, based on the information that we have, between -3 and 3 would be negative. Before -3 is positive, after that is also positive. It means concave up here, concave down here, and concave up here. So we have inflection point here and also here, but we don't know what f of 3 and -3 is. Using all this information, we can draw the graph. So we know that since the limit when x is approaching to negative infinity is -3. So y equals -3 is an asymptote. And we know that on -3 and 3, f double prime is negative, it means concave down. So something like this. But when x is approaching to infinity, the graph will be approaching to y equals 1. So it can be a graph like this. And before that, like this. And the last one, number 15. Okay, let's say this one if you want to read. Okay, we're going to find the derivative of RC, R prime of C, which is a quotient rule. So derivative of the numerator, the numerator, yes, times 3 plus C squared minus the derivative of denominator, which is 2 times C squared over 3 plus C squared power 2. After simplification, we would get 6C over 3 plus C squared squared. And if we set this one 0, it means that 6C will be 0 and C is 0. For R double prime of C, again, we're using quotient rule. So it will be 6 multiplied to 3 plus C squared minus the derivative of denominator is chain rule. So 2 times 3 plus C squared to the power 1 less, which is 1 here, and multiplied by the derivative of the inside, which is 2C, times the numerator, which is 6C, all over 3 plus C squared power 4. We would set it 0. After simplification, we would get 18 times 1 minus C squared over 3 plus C squared power 3, because one of them will be simplified. When you set it 0, you end up with C will be equal to 1. We know that 1 minus C squared, when it is 1, C will be positive or negative 1, but based on the concept of this question, concentration cannot be a negative number. So we only accept C equals 1. So using all these information for 6C, and based on this for f prime, because the denominator is always positive, so you don't have to consider that. At 0, you have 0. Before that, negative, positive. It means that it is decreasing. And after that, it is increasing. So it means that you have minimum here. And the minimum is at the point 0. And when you plug in 0 to the original function, it will be 0. And for f double prime, using the point 1 only because it cannot be negative, it will be 0, before that positive, after that negative. F double prime here is concave up, concave down, and you have inflection point here. An inflection point is the point 1 and 1/4. For part B, comparing these two protocols, since the graph is concave down when C is more than 1, the average of R at 1.5 and R of 2.5 will be less than R of 2. You can find it just by plugging in the numbers. So the greater response is achieved with a constant treatment. So for the answer for part B is the constant treatment.